In a compact 2 kilowatts to 3 kilowatts BLDC vehicle, motor temperature is not just a comfort issue. Excessive heat can shorten the life of windings, magnets, insulation, bearings, connectors, and nearby controller electronics. Yet a temperature sensor does not cool the motor, reduce current, or stop the vehicle by itself. It only measures a condition. Protection depends on whether the controller can read that signal, interpret it correctly, and apply a programmed response. Heat can build for many reasons. A scooter, go-kart, mini motorcycle, or razor-style conversion may combine frequent starts, rapid acceleration, short gearing, heavy loads, rough terrain, or steep grades. Limited enclosure space can restrict airflow around the motor and controller. Chain misalignment, brake drag, connector resistance, battery voltage sag, or excessive current demand can also force the system to work harder than intended. Peak current is only part of the picture. A brief high current event may be manageable when the system has time to cool. Long climbs, repeated launches, towing, and low-speed off-road operation create cumulative thermal stress because heat continues to build while cooling remains limited. The relevant test is therefore the recurring duty cycle, not a short performance demonstration. It is also important to distinguish monitoring, warning, derating, and shutdown. Monitoring means the controller can read temperature. Warning gives the rider an indication. Derating reduces available current or torque as temperature rises. Shutdown restricts operation at a defined boundary. A motor listing that mentions a temperature sensor does not establish which response will occur. Buyers need the exact controller documentation, pinout configuration details, and evidence that the intended input is active. The MY1020WG case identifies a KTY83-120 temperature sensor and describes thermal protection through a compatible programmable controller. That should trigger a compatibility check, not an assumption. Confirm whether the controller accepts that sensor family or a compatible resistance temperature curve. Verify the sensor connection, controller version, firmware or parameter guide, and the action associated with the selected threshold. Guessing from wire color or a similar product image can leave the protection feature disabled. The controller, motor, battery, wiring, drivetrain, and cooling path must be commissioned as one system. Programmable settings for battery current, phase current, acceleration, voltage protection, speed, and temperature limits must match the motor, battery, gearing, wiring, and intended load. A controller may protect itself differently from the motor, while the battery management system may interrupt power for its own reasons. Without understanding these layers, an abrupt power loss can be difficult to diagnose. Temperature readings must be interpreted with their test conditions. Ambient temperature, airflow, rider and vehicle mass, grade, tire pressure, gearing, battery state of charge, controller settings, and ride duration all affect the result. Establish a conservative operating envelope for the actual installation rather than copying a threshold from another vehicle. Begin with inspection of the mount, chain alignment, sprocket ratio, cables, connectors, battery condition, controller placement, and brake drag. Confirm that the controller receives a plausible sensor signal during a low-load run. Then apply load in controlled stages while recording the conditions and temperature response. Stop when there is unexplained power loss, connector heating, insulation odor, intermittent sensor behavior, unusual noise, or a response that conflicts with the configured logic. External cooling may help shed heat, but it cannot correct unsuitable gearing, excessive current, wiring resistance, battery limitations, or restricted airflow. The sensor becomes valuable only when its signal leads to a verified controller action and the complete drive system has enough electrical and mechanical margin for its intended duty cycle.